Raihan,
Yeah.
can you speak?
Hello, everyone. So our project, pandemic prediction from household parameters, is the parameters like human vital sign and weather parameters. So me and Upama, in this project. In today we are going to show the as it's more like research project, and so we are going to show our project proposal, project architecture, and detailed software. Also, we developed to showcase our research outcomes. So our goal of this project was predict a pandemic before it arrives using the parameters like the human vital sign like heart rate, respiratory rate, uh, this kind of data, and uh, from weather parameter like temperature and other related data of environment. So we actually use the three kind of data here, like parameters from ambient weather and human vital sign, and the location of human in a social, in a community setup, like where's the human actually located in a city or in a network. So uh, so uh, this is actually we are trying to put some knowledge of computer science so that uh, we can predict some unusual thing based on the data that will help us to take necessary preparedness to combat the pandemic situation and take action for preventing the situation in advance. So where is our project architecture? We can say that three part of this architecture. First one is data acquisition. Second one is like like the data processing and something like that. And then we use some model and algorithms to predict the adverse or anomaly in our data. So in data acquisition, we are currently using synthetic data that is based on the real data, and actually in our ideal model we will deploy some sensors and wireless technology that capture the data and will transfer to our server. So from this data we are processing the data and we construct our network, and we are trying to detect some change point in our data. So the change point means there is some anomaly in our data. So uh, we actually applied some algorithms to detect the change point, and we visualize uh, the uh, the change point and in a graphical representation of a application, web application. Yeah, so Upama, you can go from here.
Okay, thank you, Raihan. And in the feature set, as Raihan told that we have the vital signs from human subjects, and we also have the ambient data parameters. Now we have the respiratory rate, heart rate, and heart rate variation, and sneezing rate as vital signs. And in the weather data, we mainly are using atmospheric temperature, and the ups and downs in temperature of a specific day are also counted. The humidity level, the sunshine or cloudiness, the pollen count, air pressure, and so on. We have used synthetic data for human vital signs, which are based on the actual data, but we need a lot of data. That's why we couldn't use directly human subjects or any kind of survey. That's why we had to develop a synthetic data. We have used 3 months data from June to August of 2022. And the communities or networks we are targeting are home, school, and office where the human can reside at any time of the day. The location is Milwaukee, and we are collecting real weather data of the city for these 3 months. And we have generated above 25,000 of data points from anonymous patients, and in this data set, there could be reputation of patients as well. In the software specifications, we will show the demo, and you will see that we have developed our software or the interface inside the Microsoft Visual Studio 2022, and the SQL Server, which is built inside it, is the database for our software. The language we have used is the ASP.NET with C Sharp. For the data analysis, we have used two kind of languages. One is R and another is Python. So we have used R Studio 4.1.2 and Python Notebook for this data analysis task. We are not elaborating the data analysis task in this PowerPoint presentation. We will see it through the demo of our software. So I am switching my presentation. I'm stopping my presentation and switching to the demo. We cannot make it full screen, otherwise the parameters will not work in the full screen. So this is the home page of the pandemic prediction software, where we have admin side and user side. I will go to the admin side at first. So if any admin who are the developers of this software, or maybe who are managing the users and managing the data set, who are working as researchers for some institutions, they are the admins of this place. So they have their user ID, name, and password. If I input them, password will not be shown. It will be hidden using stars. After successful login, we can go to the current data set, and this will show the only the current data set, not any previous version. It is only showing two subjects right now from the data set, and actually it has more than 25,000 data, which is not possible to show in this page. And there is no way that we can go back to the home page here from this page, so that no one can access this page, or no one can edit this kind of data. So we have to stop it right here and start again for the user side scenario. In the user side, the users will be the medical professionals who are working with this kind of data, but they cannot access the data actually. They can only see the current graphs or the predictions the system can make. So they have to log in to make sure that they are the authentic people. So if we put their credentials, they could be doctor, any kind of health care professional, and they can also be any kind of researcher who can work with this kind of analysis graphs. And from this page, we can add something more to these pages to the user side later. But currently, we only have to display the analysis graphs and clusters, which will be shown by Raihan again.
Yeah, so here you see the zip code we have covered. Like this is actually in Wisconsin, mostly in Milwaukee. So in the next, this is the location. So this is like the distribution of data, like how much data in home, how much office, and how much school. So third is there is like the heart rates. So it's like we are using some threshold where the heart rate actually normal and abnormal. So in the respiratory rate, the same for normal and abnormal. Like you can go to the heart rate versus weather condition. uh, yeah, this is the sneezing data.
Yes, here is it.
So this is actually cluster, like we are trying to the where's the heart rate actually related to the weather condition means the cloudy or the sunny weather, this kind of thing. So we are actually trying there's in the main outcomes of this work is the change point. So if you go to the HR time series, go there in the, yeah. So this is the time series data of locations, the patients of home to. So you see the 3 months data here from June 5 to September 25. So they're actually this is actually the change of heart rate for all the uh, human in home too. So now we are trying to detect the anomaly in this data with respect to other data, or trying to get some breakpoint. So we actually use implement 4 algorithms. So using the 4 algorithm, there's two of them work perfectly nice. The first algorithm is uh, the prone exact linear time search method, that is PELT method. So if you go to the HRPELT, let's go there. Yeah, so here you see this method actually it's a algorithm that minimize the cost by using reward and penalty. So you can see there's some segmentation in this data. So this is the pelt search method, so we implement here. So if you go to the cluster and if you see there are other like the binary segmentation, this is another searching method. This is not work here so perfectly. So if you go there, there's another one is the window based search method, window. So this actually work very accurately in our case. So we can find some change point from the data. You can see there's some breakpoints. So now if we go there and we are like the HR versus temperature, yeah, this one. So you can see how the heart rate actually uh, change when the temperature changes. So you see uh, there is a detection of the breakpoint when the temperature go below. We see the heart rate actually there are some changes here. This actually this algorithm we all here we also use the PLT, prone exact linear time searching, for detect this. So similarly if we go to the go there, yeah. So if we go to the temperature versus wind speed, like there are some, yeah, or not this one. So if you go to the respiratory rate time series data, yeah. So this is the respiratory rate that change over time for all the location in a data set. So we are actually trying to build some model So if we put some real data here, that will really give some good result using our algorithms that will detect the anomaly from the data set. Like if we go there and we check the how the respiratory rate actually change with the correlation with temperature or with the wind speed or so go to the clusterings. So like respiratory rate with respect to temperature and wind speed, just go there. Yeah, so you see the first one is respiratory rate, and second one is the temperature, and third one is the wind speed. So you see there some points where that the wind speed actually increase and the temperature fall, and then the how the respiratory rate actually uh, in our data set, what's the change. So in this model, in future we will like put some real data. We're actually looking for some real data from all of us data set and from other research groups, so that we can like validate our algorithms using the COVID-19 pandemic data, so that we actually we are trying to evaluate our model that that actually use for the future pandemic, for other upcoming diseases in